Okay. So we're gonna do 7, 8, 9. That used to be funny back in the day. Why I was 6 afraid of 7? Because 7, 8, 9. Anyway. Okay. Anyway, 0, 6 pi over 6, 12 pi over 6. 7 pi over 6 is going to be here. So I'm going to split the bottom into 6 equal pieces. Or really, you can sort of kind of start to cheat at this point. I like to do the whole thing because, I'm nerdy, but you can probably figure out that 7 pi over 6 is here-ish. Okay, we're in quadrant 3. What's the reference angle? Yep, 1 pi over 6. And what's the degrees of pi over 6? Let me ask you a different way. What is it when you take 180 and divide it into 6 equal pieces? 30. So I need to use which triangle? 30, 60, 90. Yeah. Like we got it, Mrs. Talbot. We know how to do these now. Done plenty of them. Okay. I brought my handy dandy 30, 60, 90 with me. Hypotenuse is 1. Short side is 1/2. Long side is √3 over 2. Okay, then we pause here. And I think if I ask you to do this question, this might be where people forget. What are the signs in quadrant 3? Negative, negative. Quadrant 3, yeah, both negative. So the coordinate is over or back √3 over 2 and then down 1/2. Okay. 0, 4 pi over 4, 8 pi over 4. Going to be after 4 pi over 4, 4 equal pieces. Quadrant 3 again. Okay. Uh, what's the reference angle? Pi over 4. And what's the degrees of pi over 4? 45. So we should look at the 45, 45, 90. Mm-hmm. 1, √2 over 2, √2 over 2. I don't know why I put that like floating up so high there. Fix it. Okay. Quadrant 3, negative, negative. So back √2 over 2, down √2 over 2. Okay. Last one for the day. 4 pi over 3, 0, 3 pi over. Is it really in quadrant 3 again? I mean, it's fine. Move. Break up the bottom into thirds. Reference angle is, yep, pi over 3, which is 60, which means we need to go back to the good old 30, 60, 90. Okay, now before we move on, I just want to note to you that in every single one of these pictures, have I ever drawn my triangle to the y-axis? No. Is it ever chilling out in the middle of the quadrant? No. Where's the edge of it go to? The x-axis and the circle. You don't just chill your little, what did we do on the quiz here? Why do we have little triangles chilling in the, if I say the radius is 1, then the hypotenuse should be touching the circle. Now I did not mark that wrong. However, if you did this, it's definitely wrong. There should be no triangles to the y-axis ever. So if you're wondering what you got marked off on the quiz, I could talk about it because everyone's taken it now. It might have been that. Anyway, so hypotenuse is 1. Short leg is 1/2. Long leg is √3 over 2. Quadrant 3, so negative, negative, and the coordinate is back 1/2 down √3 over 2. Okay. Please find your blue sheet from yesterday. Easy, I lied. I guess I did finish that one. I guess it's second period, I didn't finish it in. Sixth period, I finished the whole sheet on the sine side, though. I don't know what happened. I got faster as I went, apparently. Okay, now I'm going to make sure that I have my erasable pen and my highlighter that does not bleed through the other side. Yeah. Am I still bitter? Maybe. Maybe. Okay. I'll come back to it, honey, or I'll give you mine and you can. Okay. So this is the last sign one, and this is what Mr. Guinan would call a whole shebang problem, which means that there's stuff in every single parameter. There's a situation, a B situation, an H situation, and a K situation. Has he said the whole shebang to you before? Yeah, he has. He's still saying it, my buddy, my bestie. Okay. Anyway, so I think this is good. We gave it overnight. So let's come back to it. A is in the front. Can everyone tell that A is -1? Okay. B is in front of the parentheses. That's 2. Okay. The period is 2 pi divided by B, which is pi. Can you guys tell me on this graph paper how many boxes pi is? 4. Everybody see that pi is 4 boxes. See where I got that from? It's from here, the start to here. Okay. H is here, but remember you switch the sign when you take it out of the parentheses. So positive pi over 4. And K is 1. So this is the first time we've had like values that make a transformation, do some kind of transforming in every spot. Okay, and so this is a really good one for us to kind of slow down and make sure we understand what's going on. First one I start with is K, always. I start with the midline, and I build off of the midline. And so I'm going to draw a dashed line at 1. Why have I not done this before? Yeah, K was always 0 before, and the x-axis is already kind of bolded. And to help you when you look back at this later, if you want, you might want to label that K equals 1 just so you can see where that came from. Okay, now we're going to graph the amplitude lines. The amplitude lines are how far away from the midline, and ours is -1. You're going to ignore the sign for now. You're just going to graph dashed lines 1 away on either side. And I'm really just going to do the top one because the bottom one is the x-axis and it's already bolded. Over here, I'm just going to make a notation that I graphed up 1 and down 1. And you're just going to ignore the sign for the moment. Okay, anybody have any questions before I move on? Do you understand why I graphed this line at 1? And then do you understand why I graphed a line 1 above that and 1 below that? And you know where those came from. So K and A. Good so far? Okay, next step is to graph the locator point. The locator point is pi over 4 comma 1. Where would pi over 4 be located? 1 box right. So right here would be pi over 4 because it's half of pi over 2, comma 1. So graph that spot and circle it. Okay, then we need to pause. Actually, not yet. Then we're going to graph the end, which is 4 boxes away. 1, 2, 3, 4 boxes away. So this is the start of my wave, and this is the end of my wave. This wave is compressed. It's squished in more than usual. Everybody see my start and my end and where I got that from. So locator point, and then 4 boxes away. Okay, now scroll up on your paper to where we drew positive sign. We need to make a sketch next to him for negative sign. That's where the negative A is going to come into play. So make a locator point and circle it. And instead of going up, middle, down, middle, you're going to go down, middle, up, middle. And that's what happens with a negative A value. It just goes down first and then up after. So positive sign starts at the middle, up, middle, down, middle. Negative sign goes down, middle, up, middle. And it should make sense to you if you think about a negative A value on like a parabola, it just flips it. So this is just flipped. Okay, so scroll down here. We have to fit that whole picture in between these. So I like to graph the middle dot next. And then because it's negative sign, my graph is going to go down first and then up. And then I'm going to highlight this is 1 cycle. And then follow the pattern. Okay, and then when you're ready, flip over to the other side. Okay. Equation name is cosine. Parent equation is y equals cosine of x. And fun fact, locator point's not HK. Locator point is H comma K plus A, and we'll talk about why that is in a few minutes. General equation's the same, you just swap out sine for cosine. So y equals A cosine B x minus H plus K. Okay, other info, we're gonna put that formulas that we put on the other side on this side also. Okay, now we're just gonna start. We've already talked about like the shape. We're gonna draw the general shapes of positive cosine and negative cosine next. Cosine is different. It starts at the top and ends at the top. So draw like a V situation like this. That's gonna be your locator point is at the top. That's positive cosine. And if you were wondering about why the locator point is not just HK, what you do is you add the A to get it to the top of the wave. So that plus A will get you up to the top. Or will get you to the bottom for negative cosine. Yeah. Can't get anything by bear. Okay, so negative cosine starts at the bottom and ends at the bottom. And your A would be negative, so it would get you down to the bottom of your wave. So that's why the locator point is different. Okay, the first one we're going to graph is the parent graph, of course. What's A, you guys? 1. What's B? 1. What's the period? Yep, and I'm going to write 2 pi divided by 1 equals 2 pi. You don't have to do that. I just want to show where I got my stuff. H 0, K 0. Okay. So I start with the midline at 0. It's already bolded. Don't need to worry about it. Amplitude is 1. I'm going to go on either side of that 1 unit. So there's my K equals 0. My A equals 1 on both sides. Everybody good there? Okay, now I have to be careful because you want to do locator points HK real bad. And you can't. It's H comma K plus A. H comma K plus A. And that's what gets you to the top of that wave so you can graph cosine. Does that make sense to you guys? Okay. Period is 2 pi. How many boxes is that? 8 boxes. So ends here. I just graphed the start and the end. So the bottom of the wave is going to be here. It's going to hit the midline here and here. And there's your cycle of cosine. Good news is we know a lot of stuff now, so we're only going to do 3 examples on this side. But the last one's going to be like a whole shebang situation. Okay, here we go. What is A? 1/2. Beautiful. What is B? 2. How do I find the period? Yep, 2 pi divided by whatever B is, which is 2 in this case, which is pi, which is 4 boxes on this graph paper. Okay, there's nothing else in the parentheses of the X, so H is 0, and K is off the end, which is -1. Does that make sense to everybody? You guys good? Okay, so K is -1, so I start with that. I'm going to make my midline down here at -1. And because it's notes, I'm going to note that that's where that came from. Ah. Okay, now the amplitude is 1/2. Luckily enough, the scale of this graph paper is 1/2. So I could just go 1 box on either side for my amplitude. Okay, let me ask you this. This is important. And I just want you to, okay, everyone close their eyes for a second. Everybody, close your eyes. This is not going to hurt, I promise. Close them, close them, close them. Okay, put your hand up if you think you can identify A, B, P, H, and K correctly. Okay, can you graph the midline correctly? Can you graph the amplitude lines correctly? Can you graph the locator point correctly? I'm assuming the hands will start to go down in a moment. Can you graph the end of the wave correctly? And can you fit the picture of the wave in between those 2 points? Some people think they have it all. Usually what happens is people get the top pretty okay. They can graph these 3 lines and then they freeze up. So I'm trying to get everyone past that freeze up point where you get the 3 lines and then you're like, I'm stuck. Okay, next step is locator point. Locator point is H, comma, K plus A. H, comma, K plus A. So it's 0, comma, -1/2 in this case. 0, comma, -1/2 is right here. Why does that make sense for cosine? Where does cosine start? At the top, right? And your dot's on the top line, so that makes sense. Okay, how many boxes away will the end be? 1, 2, 3, 4. Okay, so I've got to fit this U shape in between these 2 dots. So in between those 2, it'll be the bottom. And then the midline, this is a little like short guy. He's cute. Are you guys okay with that guy? Okay, we have one more. Okay, what I'd like you to do is take a second to yourself. Try to figure out what A, B, P, H, and K are. Just try to fill out A, B, P, H, and K. See if you can do it. Okay, look up at the screen when you're ready. Make sure you've got the negative on H. I think if anybody's going to miss anything, it's going to be that. How did we do? Everybody do okay? Okay, now I want you to draw your midline and draw your amplitude lines. Draw your midline and draw your amplitude lines. You guys know what you're supposed to be doing right now? Did you do it already and you're just waiting for me? Midline, amplitude lines. You should have 3 lines on your paper. Are you guys all not understanding how many boxes 1.5 is? Because if that's the case, I'm gonna show you. It's 3. It's 3. Do you have any questions about my 3 line? 0.5, 0.51, 1.5, 0.51, 1.5. Okay. Next step, locator point. This one's kind of spicy. H, comma, K plus A. H, comma, K plus A. Okay. What is positive 0.5 plus negative 1.5? Negative 1. And where is the negative pi over 4 box? So it's negative pi over 4, negative 1. Why does that make sense for this particular equation? It's negative cosine. Negative cosine starts on the bottom, so your locator point should be at the bottom. Okay. How many boxes is 2 pi? 8. 1, 2, 3, 4, 5, 6, 7, 8. So 4 boxes in, it should be at the top. 2 boxes in, it should be on the midline. And 6 boxes in, it should be on the midline. Why do I find them so much easier to draw when they're little? I guess that's true. That's it for the toolkit. Don't put it away though. You're going to want it. Okay. Find the resource page that's number 119 in your packet. Okay. Um, this resource page is what you're working on the whole rest of the period and the homework. Um, the key is back here. I do want to help you with one of them though before we start, before I stamp you guys. And that is number 2. So you're gonna do one on your own. It's easier than number 2. Number two's got a special situation in it that I want to talk about, but let's see what we can do here, what we know already. I hate this graph paper. I know that you're already going to hate this graph paper, so we're just gonna do our best. I'm gonna use a different color, I think. I'm gonna try this salmon-y pink color. Okay. All right, guys, what's A? 1. What's B? 1. What's the period? 2 pi over 1, which is 2 pi. H is the sticking point in this problem. What is it? H. Negative pi over 3. And K is 0. Oh, you're doing number 1? Yeah. Okay, now what I'm going to do is I'm going to grab my toolkit here. I'm going to start with K being 0. That's the x-axis. I don't need to draw a midline in. That's good. My amplitude is 1. And can you guys tell that that's 2 boxes on this graph paper? Okay. So 1 is here. The good news is I think that this graph paper is all the same on this page, which means that the number of boxes is the same for everything. I think kind of helps. Okay, so the midline is at 0. Amplitude lines 1 away on either side. Okay, now what I want my paper for really is 2 things. I want it for the locator point and I want it for the general shape. Locator point for sine, because look at the problem I'm working with sine, is HK, which is negative pi over 3 comma 0. And the reason I wanted to help you with this problem is it's hard to locate negative pi over 3 on this graph paper. Okay, so what we're going to do is go up to the very top of the page. Can you guys tell me how many boxes is pi on this graph paper? It's 12. Okay, at the very top of the page, like literally the top of the page up here. Yeah, put a little key for yourself. Pi is 12 boxes. So what would pi divided by 3 be? How many boxes? 4 boxes. because 12 divided by 3 is 4. Okay, and then remember it's negative, so you're going to go backwards 4 boxes, make a dot, and circle it. It's going to be obnoxiously large, but that's okay because this graph paper is terrible. Do you guys see that I went back 4 boxes and circled it? Okay. Now, if pi is 12 boxes, how many boxes is 2 pi? 24 boxes. So count 24. So 1, 2, 3, 4. Yeah, you could do that. Now I lost my count, Sean. It is. You're right. Because it's technically a shift left 4 boxes. Okay, and if this is 24, then the middle should be at 12. Or I could go to pi and go back 4 boxes, I suppose, if I want to do the Sean Sauter method. Do you guys know what positive sign looks like? Looks like this. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. No, you don't have to. You might want to just for yourself, but you don't have to. Okay. Um, Last thing I want to talk about, I'm going to do some stamping. There's 4 things I need to stamp. The first one is 9-84, which is a resource page. It's the one with the tangent graph at the bottom with like this, the squiggle looks like cubics, remember? I think it says 9.1.7 resource page. Do you know what I'm talking about? Okay. And then it looks like this. So you don't have to keep your packet open to that because I want you to be working on 119. But when I come over to you, if you could open it up to this, that would be great. Your notebook, it would be great if you could have that open to this homework. And if you didn't do this homework, then this classwork, which has 105 and 107 on it. So the things I'm looking for right now are this, 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 and this. This first one is not in the packet. It's the 9.1.7 resource page. And then I can stamp everybody's quiz and free box if you want me to, just to make it look consistent. Do you guys understand what you should be working on while I am stamping? The answers are right back here above Sam's head on that worksheet. So you should come check as you go frequently. Like, don't get deep in and then realize you're doing it wrong.